Hi, I'm Joanna. I'm 40 and this is my first entry for YouTube Space Lab. My idea is how microgravity affects Bose-Einstein condensate. Bose-Einstein condensate is a state of matter when a specific substance is supercooled to within a billionth of a degree above absolute zero. Then all of the electrons on its shells go to the lowest energy level and the atoms become like waves which overlap and become like a superatom. My hypothesis is that the condensate in microgravity will be denser than in Earth conditions. Condensate would be made from sodium gas atoms. So the first stage is laser cooling. Lasers fire photons of different frequencies at the atoms. The atoms absorb and emit different frequency photons depending on their velocity relative to the laser source. That is called the Doppler effect. So the photons will hit the atom, they will slow down the atom's movement, and then evaporative cooling will be used. This part involves gravity, but instead we'd use a centrifuge at 1G to mimic the Earth's gravity. The cup would be made out of a magnetic field. The more dense and cooler atoms would be at the bottom of it, and the more energized atoms would be at the top. The sides of the cup would be lowered, and the more energized atoms would come out of the cup, leaving just the coolest atoms, which would then form the condensate. And then the centrifuge would be turned off, and a computer would track the progress of the condensate. The results I expect is that the condensate is denser in microgravity. This is the state of condensate. But it may go the other way because there isn't any gravity, so the ball of condensate may not be held down as well, and it may expand slightly, or we may get a completely unexpected result because of the various cosmic rays that the ISS isn't protected from. I hope you liked my idea, and good luck to all the other contestants.